For this example, we've got a rational function f of x, which is 4 divided by 2 minus x. And we want to set up a sign chart and then sketch the graph of this function. So in order to set up a sign chart and a skeleton graph, let's identify the key properties that our graph should include. So that would be, first of all, where the function crosses the y-axis, the y-intercept. And so to find the y-intercept, we evaluate f at 0, and this gives us 4 divided by 2 minus 0, 2. So we have a y-intercept at the point 0, 2. And so while we're doing this work, I'm going to set up a graph over here to reflect these properties. So we have a y-intercept at 0, 2 that I've just marked on the graph. The horizontal asymptote, this we get by looking at the leading terms. And so the leading term of the top is just 4. We only have one term, and the leading term on the denominator is the minus x. So since the degree of the numerator is 0, that's less than the degree of the denominator, we have a horizontal asymptote at y equals 0. So this is right along the x-axis. So I'm going to dash this in red on the axis. So that's going to determine the end behavior of what happens on the far left and on the far right of the graph. For the x-intercepts, we're going to get an x-intercept when the numerator is 0. Well, the numerator is the constant 4, and so the numerator is never 0, so this means we don't have any x-intercepts. The graph is never going to cross the x-axis. For the vertical asymptote, this is going to be x values where the denominator 2 minus x is 0, where the function's undefined, and this occurs when x is equal to 2. And so this gives us a vertical asymptote at 2. So I'm going to dash that vertical line in green. And then lastly, holes would occur at any values of x that are common to the numerator and the denominator. And since the numerator is never 0, we have no common 0, so we don't have any holes. So our skeleton graph over here on the right, we've got the y-intercept reflected, we've got the horizontal asymptote reflected, we have the vertical asymptote shown, and we don't have any x-intercepts, and we don't have any holes. And so from this information, we can set up what we call a sign chart to fill in the skeleton graph above. And so for the sign chart, we're going to mark any points where we have a vertical asymptote, any x values where we have a vertical asymptote, which is at x equals 2. We would also include any points where the graph crosses the x-axis, but we don't have any x-intercepts. And we also would indicate where we have holes, but we don't have any holes. So we only have one point, one critical point for x, which is at 2, where we have a vertical asymptote. And now we can pick some test values. So I've got one interval, which is to the right of x equals 2. I'll pick a test value of x equals 3. And I've got one interval to the left where I'll pick x equals 0 as my test value. And now evaluating f at 0 gives me 4, 2 minus 0. This is the y-intercept that we already found, and that's positive. So over here, I'm going to put a positive sign. Okay, and so this tells me, first of all, that as x is getting close to 2 from the left, so as I'm moving this way, the graph remains above the x-axis, so it has to be going up to positive infinity. So sketching that, we go like this, we pass through the y-intercept, and then we flatten out as we approach the horizontal asymptote, which is y equals 0. And the other test value we have is at 3. And so evaluating f at 3 gives us 4 over 2 minus 3, which is minus 4, and that's less than 0, that's negative. So on this side, the graph stays below the x-axis. So that means as we approach the vertical asymptote from the right, the graph needs to stay below, and it must head off to negative infinity. And as I move out to positive infinity, as x goes to positive infinity, the graph approaches the horizontal asymptote. So this tells me the graph is going to be shaped like so. And so drawing that in will complete the graph like that. So there's a rough sketch of this graph, which shows all of the key properties that we would like to have shown on the graph.